Hi there, I'm Jill and I'm from Rigaku Analytical Devices, based in Wilmington, Massachusetts. Thank you for taking the time to learn more about Progeny 1064 handheld Raman. Progeny is a portable Raman spectrometer based on Rigaku's proprietary 1064 nanometer laser technology. Progeny allows the modern pharmaceutical manufacturer to analyze a wider array of common chemical raw materials with exceptional speed because spectral fluorescence is minimized. Progeny offers a versatile interface to the user, allowing the instrument to act as both a high-throughput pass-fail ID tool for the warehouse, but also allowing the quality scientist the flexibility they so often desire in onboard control of scanning and analysis parameters. By moving through this hands-on demonstration, you'll learn about the most important features and workflows for the complex needs of today's pharmaceutical manufacturer. On each of the quick demo kit cards, you'll find a specific QR code that will link to some important information about the capabilities being demonstrated on that card, as well as some additional things that can be learned on each topic on the reverse of that card. We hope that your team enjoys this opportunity to learn about Progeny in your own time, in your real working environment, on your samples. Please reach out to my team and me with any questions on the contact information found on the last kit card. So, let's get started. Let's talk safety. Progeny is a Class 3B laser device, which means that it has a nominal ocular hazard distance of 1.8 meters. Essentially, in front of the device, there is 1.8 meters of distance that you shouldn't look directly back at the laser, or it may cause eye damage. So, powering a Progeny is pretty simple. There are 2 lithium-ion batteries included with your kit. Each lasts 6 hours, constant use, and probably about a whole shift of intermittent, normal operation use. To charge a battery, you can either do it while you're using the instrument or using the external charger. Light bulb always faces up, and into the charger it goes. So we've powered on our Progeny. Now let's log in. You see your user list here. Let's use the user admin. And our password is Haya with a capital H. Let's get ready for this demo. You've got your Progeny unit, and you've got your sample kit. You may also want to collect some priority house samples at this point too. In the kit are a number of accessories, starting with the vial holder. It's a covered vial holder that allows you to use 4 ml standard vials here. All our accessories screw on and off here. The second important accessory in the kit is our nose cone. It's an adjustable nose cone that allows you to change the depth of penetration into your packaging for certain specific container types. Let's put that on now. Attaching to the nose cone is a nice bottle adapter here. This is really great for large, amber-colored, large diameter bottles. My personal favorite accessory is our universal tablet adapter. It also snaps onto the front of the nose cone and allows you to test samples like tablets really easily through this pincher apparatus, but also the typical standard small bags that you find in pharma all the time, those get held in there really nicely too. Finally, this is our periscope adapter. The periscope adapter is unique in that its mirror configuration internally allows us a deeper level of penetration into some of the more challenging container types, like thick LDPE or very large amber containers. So, let's start with the most basic of operations on a handheld Raman unit, which is verifying a raw material. Take sample A and put it into the vial holder. We'll press scan, application, and in this case, we'll select RMID verification. Let's choose our material, lactose monohydrate. Click Arm Laser and scan. The instrument compares the reference spectrum to the sample spectrum and gives us a pass-fail based on the correlation coefficient level set in our application. In this case, the correlation coefficient is a 0.96 match for pass on lactose monohydrate. Let's see what a fail looks like. Take sample B and put it in this file holder. Scan, application, RMID verification, and again, let's choose lactose as if we've received lactose monohydrate. Arm laser, scan, here we see a fail result. While we wanted to verify that the sample was lactose monohydrate, in fact we have discovered that the sample is gelatin because Progeny has searched the onboard library of 13,000 materials to discover the true identity of the material. And it's a 0.96 correlation match to gelatin in fact. By swiping right, we can discover a whole lot more about the sample as well. On the spectral review screen, we have a couple of great features to be able to take a closer look at the scans. Here, a cursor. We can stack our scans, and we can also use a call-out feature to open up other scans from our library or past experiments to add into the overlay. Okay, so in pharmaceutical manufacturing, we're always verifying that we've received what we've ordered. But sometimes, you may want to test an unknown sample. This is how we do that. Use sample C and put it into the vial holder. Go to Scan, but instead of Application, we hit Analyze. Arm Laser and Scan. Progeny has identified the material as methicel from the onboard library of 13,000 chemical spectra. The CC value is displayed, and the material identity as methicel is also shown. To observe or change scan and analysis parameters, swipe right before pressing Arm Laser. Here you'll see the fully controllable and versatile scanning parameters on Progeny 1064. Typical operation uses auto collect and auto exposure on. But you'll see here that by turning these off, we have full control over power levels, exposure time, and the ways that the library is searched. So, you've received a large batch of materials. How are you going to run those? Well, it's very similar to verifying a raw material. First we click Scan, and we go to Batch. Feels very similar to running a verification test in that we choose our application and our material. In this case, we're going to go with melamine. Entering the batch ID is next. You can use a barcode reader, or in this case, we'll go with the pre-selected batch ID. And here is where we determine the number of containers that will be tested. Select 4. And we'll do 1 measurement per container in this case. We'll click Arm Laser. We'll position our melamine sample. Push the Next button to test the next container. arm laser and scan. Testing sample 3 of the lot. Push next. Arm laser and scan. And to test the final sample, please note here that the final sample of our batch is in fact a fail. It's not melamine, and it's clearly demonstrated here in the results. Here's our batch summary. We ran 4 samples, 3 of which were passing results to melamine, and the 4th and final was a fail. Here, a quality supervisor can sign off on the batch, or we can review and rerun specific tests. Examining results on Progeny is a straightforward process. Click Results, Recent for any non-archived sampled results, and then you'll see here that all results are tabulated by the week and sortable by date. Clicking on any individual tab will bring you to that specific file and allow you to examine further. So, you never receive materials in the same containers all the time, do you? Let's look at how packaging affects the results. Start by exchanging the vial holder with the nose cone. It's pretty simple. Untwist, pull it off, and twist it on. Click Scan, then Batch. Select Total Site RMs, and then acetaminophen for our sample. Take sample E1, click Arm Laser, push the sample firmly against the nose cone, note the perfect correlation of 1.00 for the first sample E1 in a 1 ml polyethylene bag. Position sample 2 in the same way. Despite the fact that the container is blue in color, please note again, perfect correlation, 1.00 for acetaminophen. Now we'll double up on layers. Take sample E1 and put it into bag E3. And let's test. Again, note our correlation coefficient, 2 layers, 1.00 correlation to our acetaminophen reference standard. To give Progeny another real-world challenge, let's take the double-layered E1, E3 sample and insert it into E4, which is a thick 4 ml LDPE bag, and test again. Once again, the correlation coefficient holds true and acetaminophen passes in 3 layers of packaging. Let's do a final test and see what the sample looks like in a vial. In this case, for acetaminophen in a vial, the correlation coefficient is 0.97, which tells me that for this sample, it's likely that the reference spectrum was actually taken in a plastic bag and not in a vial. Barcodes are used frequently in the modern pharmaceutical environment. Barcode reader is very useful at 2 points during typical workflow. The first is to call out the material from our application list. We can press Scan, choose our application, and then using the barcode reader, call out the material. In this case, pre-selects to acetaminophen. We arm laser and scan. The results are a pass, and here is where we can use the barcode reader in a second time. By using the barcode associated to the lot ID, we can automatically enter that information here. This can be a huge workflow and time saver. One of the most unique features about Progeny is that it has an onboard camera. Use it to take pictures of incoming lots, compromised containers, finished product and packaging, or even a complete label that needs to be stored but not processed. To do so, touch the camera icon, line up your camera, and capture the image. This image is automatically stored with the data file, but also is attached to your PDF report at the final page. One of the most important benefits of Progeny 1064 Handheld Raman is its versatility. The ability to change and control your scanning and search parameters is exceptionally useful for the modern pharmaceutical chemist. So let's show you how that works. We click Analyze. Swipe right before clicking Arm Laser. Here we see scan and analysis parameters, all of which can be controlled by the developer during application development. It's important to note that multiple applications referencing the same or different libraries within the instrument can be created at any time. Auto Collect and Auto Exposure are standard operating modes for raw material identification testing. However, you'll see by clicking on any of these boxes that you can change these parameters to have full control of your experimental analysis, as well as changing the libraries that are searched and the match thresholds under these libraries. When making any change to the scanning analysis parameters, it's important to remember to click the check button to save the parameters. Adding materials to your custom library is a straightforward process on Progeny. Go to Scan and Analyze. First, we want to make sure that Progeny is set to the default Auto Collect and Auto Exposure settings. To do this, swipe right and then click the default button. Check to confirm. Then, we position our sample. Best practice is to use a 4 ml vial for your sample collection for your reference spectrum. Use the vial holder, position your sample, and press Arm Laser. You're going to examine the quality of the spectrum. You want to see sharp peaks with a very high signal-to-noise ratio, something above 3,000 to 1. We see this. To add it to the library, all we have to do is push the Library Add button. We can enter the material name, press the check mark to save. Select the library that it's going to go into. In this case, I'll put it in our user library. And as we see here, it's into our user added library. Good manufacturing and laboratory practices require us to do some standard daily verification of the performance of our instrument. For good manufacturing practices, run a performance verification at the start and completion of your shift. To do so, press this icon, and then choose Performance Verification. A number of materials can be used. In this case, we'll use benzonitrile, arm laser, and scan. We achieve a pass for the daily performance verification. In the case of a fail, the user can complete an instrument calibration, which will calibrate the position of the x-axis to the selected material reference. So, you've generated data. How do you export it to your server or local PC? Progeny offers two methods for this. One's pretty simple and straightforward via USB. Progeny is also Wi-Fi, so you can connect wirelessly to your server anytime and download data directly from the warehouse floor to your secure server location without ever connecting by a cable.